Okay, so we have this equation, and this is the equation. What kind of equation is this? Well, this is hyperbola because it has minus in the middle. Remember, if there's a plus, if this was a plus in the middle, that would be an ellipse. But it's got minus in the middle, so it's a hyperbola equation. And first off, it wants us to find the coordinates of the center. Well, that's actually pretty easy, isn't it? To find the center, you just take the opposite of whatever's next to x and the opposite of whatever's next to y. So that'll be minus 7 plus 3, x, y, opposite. And that's in the notes. Let me show you down here. Graphing a hyperbola not centered at the origin. The center is the opposite of the numbers next to x and y in the original equation. So plus 7 leads to minus 7, minus 2 leads to plus 2. So yeah, it's opposite. So we just take opposite of plus 7, minus 7, opposite of minus 3, plus 3. So there we go. We've got the coordinates of the center. That's the center of this hyperbola. Then it wants us to list the coordinates of the vertices. List the coordinates of the vertices. Well, to do that, to list the coordinates of the vertices, we really what we want to do is to, we got to graph the thing. I mean, they'll say we have to graph it, but it'll sure be helpful. So I'm going to come over here and graph the thing. See, minus 7 up 3, and then, okay. Right, okay. So, oops. Okay, so let's graph this thing. And it says, say the center, first off, is back 7, up 3. So let's find that. So back 7, 1, 2, 3, 4, 5, 6, 7. Back 7, up 1, 2, 3, up 3. Right there. So there's the center of the hyperbola right there. And now what we need to do is form that box that goes around it. How do we do that? Well, it's whatever's here under the x and the y. So square root of 4 is 2. That means up and down 2, up 2, down 2. And underneath x squared of 36, 6. That means right 6, left 6. So 1, 2, 3, 4, 5, 6 right there. I went right 6. I just went 1, 2, 3, 4, 5, 6. And then left 6. 1, 2, 3, 4, 5, 6. Right there. And then make your box. So with a hyperbola, we make a dotted box. Like that. So, and that's what they're saying in the notes. So graphing a hyperbola not centered at the origin. How do we do it? Well, it says the center is the opposite of the numbers next to x and y in the original equation. Got it. From this center, go right and left the square root of the number under x, right? Square root of 9, 3. See how this goes right 3? You know, from the center right here of negative 7, 2, they go right 3 and then also left 3. And then from the center, go up and down the square root of the number under y, square root of 16, 4. So they went up 4 and down 4, and then they made this dotted box. And then you put the diagonals in, the dotted diagonals, which are the asymptote lines, which guide the branches. Okay, so let's do that. So now you do the diagonal lines, go from the center, go right out the corner and the other corner, and then that corner and that corner. So you do diagonals right through the 4 corners of the box. That's why the box is so important, because we got to get those 4 corners. And the diagonals, those are the asymptote lines that will hold the graph branches. It's going to hold the 2 branches. Now, there's 2 ways these branches can go. They can go up here, top and bottom, or the branches could be right and left. It's not both. It's one of those, either top, bottom, or right, left. How do we know? Well, it's all about what's in front. Like on this one, it says, Because x squared is positive in the front, the branches go right, left. So this one had x squared in the front, so the branches go right and left, right? Or this will tell you too. If x squared is positive in the front, again, right, left. If y squared is positive in the front, branches go up, down. What do we have? Y squared. So we have, let's write that. We have y squared positive in the front. Right there, whereas the x squared is negative. See, the x squared has a negative on him. The y squared positive in the front, so that means the branches go up and down. Now, they always start in the middle of the box. Did you notice that from the notes? Let me show you. See how the branch right here hits the middle of the box. And same thing if they go right, left. They always are touching the middle of the box. Same thing on this one. See how this branch right here hits the middle of the box. It starts from the middle of the box, either right, left, or up, down. So ours is right, left. No, I'm sorry, ours is up, down. We have y squared in the front, up, down. So it's going to start right here and right here, middle of the box, and do what? Go out to the asymptote. So here we get very wide. That wasn't a very good branch, but good enough, whatever. We're getting super wide branches because of the way the asymptote lines go, because it came from the box, right? So there's a graph. There's a graph. Now, it's asking us to list the coordinates of the vertices. What are the vertices? Well, if you look back here, it, what does it tell us? Maybe on this graph, but yeah. See how it says vertex? It's right there. Vertex right there, or vertex right there. Vertex. So it's those 2 points where the branches hit the box. Those are the vertices. So this is a vertex, and that is a vertex. So what are the coordinates of those points? Can you tell? Well, this one looks like they're both back 7, huh? This one looks like it's back 7 up, what, 3, 4, 5? This looks like it's up 5 to me. Yeah, up 5. Back 7, up 5. And then the other one is, oops, back 7, up only 1. Yeah. Back 7, up 5, comma, back 7, up 1. And you can put them in either order. You can put the back 7, up 1 first. It doesn't matter. Make sure you put a comma in between them. Like that. So I'm listing both of the vertex points, the 2 vertices, and giving the coordinates, back 7, up 5, and back 7, up 1. There they are. There's the 2 points. That's all they want on this one. Yeah, so so you can find them on the graph, or really, where did they come from? What was underneath y, square root of 4 was 2. So we really just added 2 and subtracted 2 to the y value. Notice from the center, it was up 2 and down 2 to the vertice point. So I added 2, 3 plus 2 is 5, and 3 minus 2 is 1. That's another way of getting those 2 vertex points, those 2 vertices. That's really what's happening there. You go up and down 2 from the center. You add 2 and subtract 2 from the y coordinate of the center, because the branches go up and down whatever's underneath y. So there we go. They don't want the graph, just those coordinates.